Hello. Uh, so you heard the disclaimer. I hope you don't have too many expectations to hear about design patterns today. It's not about that. And I'm here with a small mission, I can say, a mission where I believe we spend a lot of time discussing technology, choices in technology. We usually focus a lot in the design of software and design of code. Uh, but then we also tend to call that somewhat architecture, and of course there are bigger things that we call architecture, but we not often spend time like ensuring how do we make architectural decisions and how do we mitigate the risks of those decisions, because people make mistakes, not all the decisions are great, and then if it's a bigger team or bigger organization you're in, you usually want to ensure each next architectural decision has a better success than the previous one. So today will be about that, and together with my team or teams in Danske Bank organization, we spent quite some time to figure out, the best practices and a thing that I will call architecture definition pattern. But then before we start, I want to set a bit of a context here. So as you heard in the intro video, I'm Vidas Vasiliauskas. I'm heading one of the software development departments in Danske Bank, Lithuania, as well as I'm this year still lecturing in Vilnius University a subject of software architecture for master's grade students. And what I'm trying to do here is like I'm bridging academia world with business world, and as also you've heard, there is a fine gap between theory and practice, and usually it sounds very easy when you lecture, but then it's not that easy when you try to do that, in reality. Now, to better understand where I'm coming from, in technology space, I'm a software engineer myself. I've been doing that for probably at least 10 years, I think, maybe more. But now I'm a manager, a technical manager, I would still think of myself. And I work, as said, in Markets IT. Markets IT is an organization consisting of 294 people, which develop and maintains around 70 systems that is being run on infrastructure of a size of 2056, both virtual and physical servers. So that is just to understand, the organization size and what we do in IT. And then my department, which is called Trading Services, is one of the departments in that markets IT area, and we mainly focus on trading platforms. And markets is like it's a bit crazy world. It's slightly stressful. It has a lot of changes going on. It's heavily regulated, and everybody wants to compete. Everybody wants to have competitive edge over the other players in the markets. So software as well tend to change quite often, and sometimes it is very large, it is event driven, it is distributed, and there's a lot of features built in. So my department is 5 teams sized, teams, or some of them are called squads because those are small groups of people. Usually it's 5, so you can do the math how many people in total. It's split across 2 countries, in Lithuania and Denmark. And then I thought, well, what could be also a good hint for you how much IT work we do. So I just went into our deployment pipelines, and I just simply calculated how many unique services we have. It's 271. So it's 271 component that we maintain or still develop or want to ship from time to time. And then I tried imagine, so how many times our engineers had to sit down and make decisions that probably are overlapping in some other components. They made maybe similar mistakes, or maybe they made different approaches to the same problem. So this is where architecture comes. This is where you want to be, efficient and good at it. This is where you want to put things that are time proven, results proven, and you want to make sure that it's shared, that other people can learn from it. Just before we move in more into the context, this is university coming from my heart, saying, let's understand when we say what is architecture and what is design. I still sense there is this thin line between these two things, but architecture is something that is significant. significant enough. In here, there's a good definition saying its significance is measured by the cost of change. And usually this cost of change is involving, when we talk architecture, it involves systems. It involves multiple systems, communications of systems, subsystems, sub-services. And then when you go to modules, this is it. This is where the thin line between architecture and design starts. And then when you go into components, libraries, classes, methods, functions, code base, that is your design. So today, it's architecture. And architecture usually is something that involves a lot of people. And a lot of people means you need to be very good at it so people are aligned and communicating together. And whenever you do things in architecture, you make decisions. You choose technology, you choose approaches. So those decisions are the essence of architecture. And for me, it looks like, as in this picture, it seems like, a muddy road. And then each person, by looking at it, might have some gut feeling. And I'm a bit of I have a hobby of, racing and driving and maybe off-roading. So this for me has a gut feeling says, it's risky. You might get stuck if you drive there. And then I know this gut feeling because I experienced this numerous times, shoveling myself out of trouble. And then the other side of this gut feeling could be theory. What you learn in university, what you read in the books, what you watch on YouTube videos, something that you know but you have not yet experienced. And these are the two sides, experience, theory. So then when you have both, you're lucky. Then you have less issues making wrong decisions. But when you don't, when sometimes you only know theory, or maybe you know only experience, then you need some sort of a guidance. And this is what we kept figuring out in our organization. Like, so what are those guidelines? And in these, real life situations, you have road signs saying, that's a dead end. You should not go there. And it's easy then. You can make a decision by just looking at the road sign. And I don't want to go there if it says dead end. So this is what is architecture definition for us. We want to make sure that these decisions are properly guided. But before we start with the proper guidance, I still want to tell you what is the wrong guidance. It's the fun part of this. So this here I will call common smells and anti-patterns. I will also, I'm standing already, and then I will say, well, if you want to be acknowledging that you did something wrong, which is a very nice feeling, feel free, just stand up whenever you feel that this is something you did in the past. I keep doing those, don't worry, you're not alone. So the first one, and my favorite one, is called CV-driven development. So you pick a technology and you say, okay, I want to do this because it will look very nice on my resume. Does that sound like a good choice? Is it a good decision? Probably not. For you and your resume, maybe, but for the system, that could be a bit wrong. So this happens in engineering world. Anybody wants to stand up and acknowledge that? You never done that. You're perfect. I will do sit-ups for you all. Next one is truck factor of 0. What does that mean? Well, a truck factor tells you how many people in your team can be hit by the truck and you can still survive. You can still deliver. There are people who knows other people code and they can still, develop application or software that you're running. And truck factor of 0 means every person in your team is key. It's only one person knowing something. If that person's out, that's it, your team's done. Doesn't sound nice. There's the inverse truck factor, right? It's more awful to hear about it. But in some teams, it says inverse truck factor says how many people in the team you actually need to be hit by the truck so you can start working. But don't practice it. Just solve it somehow. I've seen organizations in my very early career days, and oh boy, it's not fun. And let's move on. There is a third one called single horse race. This one is very simple to make because whenever you're in discussions, like imagine you have an architect in the team and he comes into the meeting and says, we had to pick this messaging system for our new event-driven software. I picked RabbitMQ, and then, well, it sounds nice. I think we should use it. And then everybody says, okay, okay, sounds like a good choice. So, but how many alternatives have you considered? And says, why do you ask? Only one. Easy, right? Then it's a clear winner. No alternatives discussed. And the last one is oh boy, that's a sneaky one. So I call it ninja move. And ninja move is when, imagine a situation where it's like 2 days until your, big launch or demo day, and then everybody again gathers. So how do we do this? Do we have everything in place? And one of the senior engineers comes and says, guys, you remember that core transaction service that we were planning to do just before we launch? Well, I did it in Ponylang. What is Ponylang? Who knows in the team Ponylang? Do you know Ponylang? No, I don't as well. If you know, let me know. I passed the number. But the problem in here is that it's already too late to change it. 2 days remaining until launch. That's it. Somebody snuck in some technical decision without everybody knowing. And then you got to live with it. So these 4 is which I will use as a lens what to avoid. This is not nice. This is what you want to recognize it. I'm happy that I recognize this, and I'm happy that sometimes when I start doing this, I say, oh, that's the anti-pattern. Let's avoid it. And then when we know what should be avoided, we should also think, where do good decisions come from? What drives the right ideas? And also we sat down and said, so let's list down things that influence us positively, in positive manner. And in positive manner, we've listed out, like, it's a lot, like 6 things, but it doesn't mean you need to apply all of them at the same time. Each solution you make can have only 1 or 2 drivers. That is enough. And that is what I call architecture drivers. Not the guys standing by the wheel or sitting by the wheel. Those are real drivers. But if we talk about architecture drivers, we talk about things, that's a cheesy one, company vision. But for me and for my company, when we talk, like, what do we want to achieve as a whole organization, we say, we're customer first. We're very focusing on customer experience, on customer journeys. And that means then when I develop software, I really want to understand how does it influence my customers or my company's customers. I want to see some sort of tangible bridge between that, because then I can probably even offer better decision. Next one is business strategy. Very simple again. If my organization says that we are competing in a market where there are more than one player, maybe we want to offer better pricing. How can we offer better pricing? We can offer better pricing by having cost-effective IT infrastructure. Maybe that means running on the cloud. Maybe that means optimizing our server count. It can be any of those. But that is business strategy tying together with IT. Then the third one is user habits. User habits influence a lot because it really depends what kind of software you make. If you make it for people who really needs, eye candy, nice software like retail clients, then you usually make user experience based software, which is very, fluent. It has nice, look and feel. If it's internal software, that can be mainly productivity driven. For us, it is the case. So my end users who are traders, well, their days are crazy enough. Sometimes they earn millions, sometimes they lose one. Well, not nice, right? So you want software to be as efficient as possible, automated. It needs to be actually very nicely tied or macroed in the GUI itself, or even backend doing a lot of things instead of the user. That drives your architecture. Then development model. A development model is something it could be as simple as we say in Danske Bank that we want to be able to ship our software, any version of our software, to any particular user. Meaning we can have features like pilot users, meaning we can actually roll back for one person or roll back for everybody. We can roll forward for everybody. It gives you a lot of flexibility, and then you reduce risk that software changes make. So that can influence your architecture as well. IT strategy, every bigger company probably has some sort of a centralized governance on IT, and then that central governance usually gives you freebies. Sometimes they invest into creating some reusable infrastructure. Sometimes it is technology that will be used in every development team. That's where you get things for free. And then maybe you want to look at that and then actually also positively influence your development efforts. The last one is technology trends. And technology trends is something that you look like we still want to be relevant for the workforce we hire. We still want to be we still want to be relevant for the workforce that's already working for us, because it's not nice to work on old technologies. It's not nice to work on technology that doesn't fit the purpose. So that also influences your architecture decisions. And just before now, I will start introducing you to the actual solution. Let's see the last bit. Now we know what to avoid, how to positively influence our decisions. Now we need to think, when do we make those decisions, right? Time-wise. And time-wise, this is the chart that is a common sense, right? The earliest in your project or software development life cycle, you have more options available, alternatives as architectural decisions, and then the cost of change is relatively small. If you go further on, it changes. Cost of change goes up, options available goes down. So common sense, right? You want to make them as soon as possible, but not blindly. You want to build context and knowledge before you make that decision. That is as soon as possible. You shouldn't like, let's pick one. This one's good. No, that's the wrong way of doing it. So you want to maximize your architecture definition here. And this is what we look as a third thing. So by knowing all these three key ingredients, we started thinking, so what, together with engineers, we started thinking like, so how do we ensure this happens? How do we ensure in our daily life this is a repeatable success for us? And it needs to be simple. It needs to be a simple recipe. And it started as a very, very bold and boring name that we came up with, architecture committee. Jesus, who calls things committee? That's like, a public, non-profit organization or whatever, gathering from time to time just to talk, drink coffee and, laugh. But we said this serves purpose because whenever you tell everybody that's a committee, everybody knows what a committee is. If you don't like the name, call it, Ninja Movement, Avengers, or whatever. But what is this committee? Committee is consisting of numerous, not one, not two, but at least few very strong professionals, experienced strong professionals like these guys. And then it's somebody who gets in that committee who knows also by experience what are the problems, also might know few good solutions, also by experience or theory, and then usually they're, interested in working with architecture. They know the significance of good architecture decisions because they probably have seen numerous times when it doesn't work. A second piece to this small recipe is architecture owner. You still want somebody to be responsible. You want to have one person responsible, because whenever everybody's responsible, then you start pointing fingers. No, you, not me, you. But architecture owner is also the most strongest person in the team. He or she is the one who has enough technical respect points to make unpopular decisions and still get away with that, right? Not all the decisions you make are good. Sometimes you make bad ones, but you still need to get away with that, because then people still maintain trust. And the last one is the third again. It's the time. Usually we create features, we help business achieve their goals, but architecture is something that gets always, saying important, but not urgent. And it gets down prioritized from time to time or often. And then this was a constant battle for us. So we added that into the mixer, and then we got something we call architecture definition practices. And now let's see what those practices for us are. And we initially started by saying that we need to have some sort of a plan, some sort of a living content that will guide us through this ambiguity, through the unknown, so we can start not looking at every piece of software we have, every corner we want to fix, but we somehow want to see where is the low-hanging fruits first, where is the the best value for our buck. And then this was like, yes, let's, for any product or software piece that is big enough, let's create a strategy of architecture. And that strategy is just a very simple template. Each product could have one of those. Maybe a group of products could have one of those. But it's something that guides you through the dark times. So we have chosen free drivers that we care about in specific product. This will be actually a living example of one of our products. And we said we want to be focusing on business capabilities as a driver. So whenever we create software, we need to figure out how do we actually gain some competitive edge by doing something in IT world, so our business is happier than it was before. Second one, evolution. Remember I mentioned those fast-paced, constantly changing, regulated environments that we work in. So whenever you talk about software change, that costs time, money, people, efforts, emotions. So you want to pay attention to that. How do we make sure that our changes are easy and painful? Last one is run cost. If you don't have good evolution, of course, run cost will also be a bunch of shortcuts taken, and then you will spend more time in operations of software than development. And development is fun, right? At least that's what I think. Development is more fun than operations. And then we said these drivers should influence our key initiatives. And then key initiatives is something big that can take, at least few months in time to achieve. And then we picked few. We said, okay, we have a lot of distributed data around our organization. Maybe we can centralize. Maybe we can create a data backbone where we can give our business better business intelligence on top. Maybe some, big data analytics on top. Other one was like, our product is a rich, thick, big platform. Then we said, let's split it a bit, because releasing that or shipping it at least if we want to ship each day or each week, it's not that easy. It takes a bit of time. So let's relax that a bit. And then if you see each initiative has a driver stated, which drivers influence this initiative, and then of course it has responsible person. I didn't put real names. Some of the guys might be here and they don't like to be responsible maybe for that today. They're in conference, so let's have a relaxed time. And then the big initiatives, they're big, right? So not often you have enough time to do that. So we said, okay, let's pick a few smaller ones that can be achieved in a week's time. So whenever you get blocked or you don't have enough time, you switch from big one to the small one. And then again, they still need to be influenced by drivers and have somebody assigned to them. And then here's the evidence, actually in the next slide, that I'm not hallucinating. But just the last bit, it needs to be time framed. We also want to say that it needs to happen in some point of time, and it's 2019, first half a year. 2 months remaining. I don't know if we can accomplish everything, but we will do our best to go there. And I'm pretty sure this as actually a good template that supports and defends a bit how you make the decisions. And now this is evidence. This is a living wiki document inside of our organization. It's a bit more verbose, so I try to simplify it. But any bigger product could have it, and then everybody can go access it, read about it, and then every engineer, either a new joiner or very experienced senior, can always get back and look at it to understand why we do things. And it's not about the code. Code sometimes is easier to explain because of method naming, variable naming, because of structure and functions. But in here, in architecture, it needs still to be somewhere explained, and then it's quite far away from code. And then whenever you do those decisions, you understand, so how do I record the decision? How do I explain it? And we picked, okay, so we want to be as close to the code as possible, but some solutions are composed of numerous repositories. Some of them have like hundreds of repositories. So what are the options? There is no one size fits all. So we said, okay, we take free. We recognized free proper ways of recording decisions. And then we made a small, a picking guide where we say two questions, two very simple questions. One, is this decision applicable to more than one solution, more than one system? Is it generic enough so we can actually make this one time and then everybody can benefit from it? If the answer is yes, we call it ADR. That's actually already not something we invented or created. It's quite actually right now gaining traction, a popular way of recording architectural decisions. It's called Architectural Decision Record. And it's a very lightweight thing. And we said, let's put it as close to the code as possible. So we put it in Git repository with together other generic ADRs, I will use this abbreviation, ADR. And then it has also a template. Surprise, surprise. I try to illustrate this template by making a bit of fun here. So imagine, what if we were to pick a general purpose language? Because we want to shift people across the projects, we want everybody to know what kind of other people are doing, and so they don't need to learn new stuff constantly, like every day if they join other project, or if somebody gets sick, or if somebody gets hit by the truck. So we state the thing we want to solve, then we say what's the status, is it accepted or is it still in progress, because it takes time to make that decision. We state who made the decision. Well, I made this decision, and then I made it today, so I'm bringing some surprise to my engineers when I get back to work. And then we want clearly state what's the problem, what do we want to solve, what's the context about the problem, and we said, well, as I just mentioned, we want to make sure that we have good cross-functional teams that can easily, edit and develop each other's code. So general purpose language seems like a good attempt. Then we want to mention decision drivers, and in here we just said it's our IT strategy, because we say we want to work as cross-functional teams and cross-location teams. Then we state, remember that single horse race, we state at least 2 available options. In here, for example, I took C# and F#. Now, who do you think won? Which one? C#. What I hear? Visual Basic? Oh, man, no. Java. Okay, maybe Java could go also in here. Good suggestion. But, well, unfortunately, F#. The decision outcome was F#. And then, okay, by the way, I saw some guys from that. Don't worry, it's just a joke. You won't go and code in everything in F#. But how did we pick it? Why? Where's the explanation? And we said, well, I said, I'm a grown-up, I'm a mature person, I should make a very argument fact-based mature decision. And then it was easy. C# does not have a keyword called fun. F# does have a keyword called fun. I want to have fun. F#. And then if it was a proper argument, there would be links and references to support it. In my case, I'm a mature person, I don't have references and facts to support it, only the fun. But that's the template. It shields you from single horse race. It also shields you from those ninjas moving around with their, unknown decisions a bit. And then it forces you to think about it and provide pros and cons, fact checks, references. But in broader terms, sometimes I see this called lightweight architecture description record, because when I in university teach people, it's like you teach a lot of things, big methodologies. This one is actually good. It serves purpose. Fast, easy, reusable. And then as you see, all the architecture description records can live in single code repositories, so everybody can benefit from history, pull requests, all these niceties of code repository. If it's not broad enough, if the answer is no, you ask second question, is it specific to any solution, single software? If the answer is yes, then there's a thing we call project page. And a project is, some sort of a development effort that takes at least few months, and then you need to, at least contribute few people into it, so that's already a project, that's not a task. And then project page is specific to that project. And it has few principles. First, it needs to contain business context and documentation related to it. So people can go in and see why the hell we're doing this thing. What is the end value for the business? Then it tracks milestones and deadlines. It's again living document, and it can be anywhere. Good examples could be, a README files in GitHub repositories. If the project contains multiple repositories, then it can be some sort of a shared wiki. But it's somewhere where people communicate. Everybody, it's accessible to everybody, not only the engineers, because there are many stakeholders. Then, whenever we start, remember that chart of time versus cost. So we want to make sure that we make these decisions as soon as possible, and if we need to fail, we fail. We want to make sure that our engineers do napkin designs just before they start developing something bigger. And then we say that needs to be supported by diagrams. And this is just an example. Stop reading. It's internal. Don't read. But it's just an example, what you might have as a diagram in that project page, which tells you what is the setup of solution, or what is the architectural relationship between architectural elements. So it is a principle. Before you start the project, you need to have that. Then it facilitates communication between all the stakeholders, IT, non-IT. It's owned by project lead. Who is project lead? Well, a project lead is also a very strong professional from that very experienced professional team we call architecture committee. But then this guy, or this guy, it doesn't matter. But architecture committee needs to assign a project lead to each project. And then I will soon tell you what that project lead does in the projects. Usually, he or she might code or might not. Lastly, the project page needs to create it prior to the actual coding. It's a good thinking framework. Lastly, if this decision is specific only to a single piece of code, one module, one library, one single service, then of course it's a README-MD file. Because it will have design decisions, less architecture, more design decisions. So then it's simple as that. And then, of course, we have some templates. Of course, they are sometimes verbose. I won't tell you about that. I will tell you just few things that come into that README-MD that are still relevant for architecture. Maintainer, meaning person who either originally created or who is the last one who is responsible for that specific code piece or code base. So whenever you want to do a pull request or whenever you want to consult about choices in technology, you know who to. That's again your living argument, who you need to go to. And then it needs to describe and explain architecture or design choices. So now we go to the meat, the main point that I was leading you to. This is what we call architecture definition pattern. And it might be a bit brain damaging if you look at the whole, so I will go step by step. We have architecture owner. Architecture owner who organizes architectural committee. That person needs to be good at organizing and making sure that's progressing forward. On the side, you have architecture drivers that positively, in altogether of these three pieces, influence that strategy that we create for each product or for all of our products, but they influence, drive, input, own. Then when you have that set up, two practices comes out from committee. Committee assigns project leads, and then architecture strategy outputs ADRs, which are generic, either to the whole system or group of systems. Then project lead supports software engineers that work on projects, while ADRs support and describe project architecture. Now, project lead is also a quality assurance person, but on architecture level. That experienced, strong professional can go in and say, okay, so what are the choices? Are they correct? Do we conform to our strategy? Do we conform to the description records? And software engineers are still also architects themselves because they define architecture in there. They pick choices. They pick languages. They pick libraries. They pick technologies. They pick communication patterns. It's hands-on. On the side, each project has a project page that describes and supports both architecture and software engineers. And it also, it's like, it's sandwiching. So you have less risk of making something wrong. Of course, project architecture needs to output some sort of a project results. Software, code, technology, which needs to be a continuous feedback. Because in theory, sounds nice, we need to prove it empirically. Prove it, how does that work? So it's a continuous feedback back to our strategy, back to ADRs. Is this correct? Have we proven already something? Is it acceptable because we have done this in one or more projects? And then this pattern, it seems complicated, but there are only a few practices to perform. You just need to be very aware and agree with everybody. That's the way how we do it. And then we've discovered a few caveats during our journey. First one, again, important but not urgent priority. Things doesn't move if you do that. Lack of transparency. Oh, that was like, Illuminati group at first. Oh, nobody knows about the architecture committee. People gather, make decisions, but don't tell anyone. And then someone says, why did you make this decision? We already decided that it's not going to be this way. How do I know? Nobody told me. So now we know that. We need to be very transparent. Then scope management. Don't be too ambitious. It's very hard to prioritize and do bigger things. Then indecisiveness. This is where your architecture owner comes in, because usually, democracy sounds nice, but if everybody is voting for their own decision, there is no, clear winner, and then it's stalemate. So architecture owner comes in, smashes the table, that's it, we go this way. It's not the best choice maybe, but it's a good choice enough for this time. And then maybe he or she will be able to get out if it's a wrong choice. Lastly, it's D word. Who knows what is D word? Come on. I won't repeat that. So it's documentation. It's the scariest word of them all. Like somebody says documentation, oh my God, somebody said D word, I'm out. So you want to avoid that. So again, closest to the code as possible. Then it doesn't smell like documentation. And then it's very easy to make it the first time. It's easy to write it the first time. It's easy to capture something as a text. It's very hard to continuously maintain it because things change. But that's it. That's what I had to share today with you.